Find the midpoint between these 2 points. Let's try to use some common sense and get her done, as the one guy from the one thing would say, before actually doing the math. What would the average value of the x portion of the midpoint be? Can you do that off the top of your head? I'll write down the formula and I'll wait.
I think I don't know. Never mind.
It is 1. I think you were gonna say 1 and then you got scared.
I was.
What?
I was, because negative 2 plus 4 is 2, and then 2 divided by 2 equals 1.
That's it. So tell you what we'll do is I'll edit that part out and I'll ask the same question again. So what do you think the first x value is going to be, friends?
1.
Yeah, very good. Good first time shot. All right. If I were to label things, yeah, you do get x sub 1 and there's my x sub 2, and you would get negative 2 plus 4. So I'll just write out what that is, which is 2, and 2 over 2 is 1. Good. What would my y values be?
1 and 3, I think, because I don't.
Yep, and so add them up.
That would be 4, and then 4 divided by 2 would be 2.
Good. So my midpoint at this stage, and those of you who practice that IXL, you should feel pretty comfortable figuring out your midpoint mentally, because we did it so many times. So good. I will be able to measure and draw angles. This is easily one of my favorite math memes that's out there, because it mocks people who can't spell, and I just love the fact that on the bottom it says, "I love you, sweetie." If you don't get it, that's okay. Oh, yoga. Oh, I know what yoga means. Yoga means you only live once. Let's talk about a man named Ray. Now, this man named Ray looks like Mr. Lucia, as one of you said. And what he is he has an endpoint, and the other part he goes on forever. So Ray is basically just an arrow that starts here and goes on forever in a specific direction. It's called a ray. If you choose a point on a line, that point determines exactly 2 rays called opposite rays. So like H ray, HK. And again, when I name a ray, I start out by naming the end point, and I end naming it with the thing that goes on forever, with a line part. Okay. Mr. Line Chia, Mr. Lucire. His name's Sam, so I really can't do anything there. Samuel. Sam. But anyway, this is called BA and not AB, because B is the end point. When you name a ray, start it with the end point. So if I was talking about just the part, if I were to name ray HK, that means I'm talking, oh my gosh gracious, I would be talking about starting here and going that way. And so these are opposite rays where they face off in the opposite direction. Rays. Did you know that the Native Americans used to call corn maize? Well, we're going to call these things rays. You probably have never once heard of this word before, an angle. An angle is formed by 2 non-collinear rays. An angle is formed by 2 non-collinear rays that have a common endpoint. So there's your angle down there. You've probably never seen one of these before. This is called an angle. The rays are called, this is going to blow your mind, sides. The common endpoint is called the vertex. So this is side XY, that's side XZ. And again, it's not called YX, it's called XY because it starts at X and goes on forever towards Y. And this is called XZ because it starts at X and goes on forever at Z. And instead of calling that a corner, we call it a vertex. Unmute yourself and tell me the plural form of vertex.
Vertices.
Very good. Very good. You already know this too. When we name angles, there's 3 possible names that we can name this John down here. Whatever you decide to name it, make sure, well, okay. If you're going to give it a 3-letter name, you have to make sure X is in the middle. So you could call it YXZ. angle YXZ. You can call it angle ZXY. You can call it angle X. You can call it angle 3 because that little 3 there indicates the specific angle part of that. Okay, you can't call it angle XZY or XYZ because by calling it like angle XYZ, you're implying that Y is the vertex, Y is the middle. And we don't imply. You know what they say? When you imply things, you make an imp out of me and a ply out of you. Nobody's unmuting themselves to laugh. Well, that's probably because you're afraid to laugh.
That was so funny.
Thank you. I can't wait till we're in person. I'm just so excited. Oh, an angle divides. Ooh, I bet you didn't know this. I bet you didn't know this, friends. An angle divides a plane into 3 distinct parts. So if I were to get a piece of paper and cut an angle out of it, okay, it creates 3 things. But what we're going to care most about is the smaller angle is going to be called the interior. This side is the interior of an angle. So imagine you have Pac-Man, okay? And no matter how big Pac-Man's mouth is, if Pac-Man be eating something, that's the interior of his mouth. If Pac-Man not be eating something, that's the exterior, okay? But instead of Pac-Man being a circle, the world is our Pac-Man. So these guys are part of the exterior of an angle. So they say that S and R are the interior, the interior of the angle, and P and O are on the exterior of the angle because it creates a larger space, so to speak. And then Q, M, and N are neither because they are the angle. They make the angle. So I have this goofy looking picture here. Sorry. What if Pac-Man was created to teach angles? You know what? Maybe he was. Thank you, Paul. It says name the vertex of angle 4. Here's angle 4. Vertex is the point. Good thing that when I post this online, you can't see the comments in the chat. There's my 4. What's the vertex? Unmute yourself, please.
You.
Soldier Boy, tell them. Soldier Boy up in this O. Watch me crank that. Watch me roll. Watch me crank that, Soldier Boy, and Superman that beep. So I have angle 3. And it asks you to name the sides. Let me name one of them for you, and you could tell me the other one. That's the side right there. That's one of the sides. And since I start out at X and I go on forever at W, I'm going to call one of my sides of angle 3 ray XW. What's the other side of angle 3? One of you had bravery for a second there. Does it start? Is it a? Well, okay. One more time. This is ray XW. What's this one going to be?
XZ.
XZ, but what XZ?
XYZ?
Nope. Ray XZ. Ray XZ. XYZ is a line. Although, oh, okay, I see what you did. 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 What is another name for angle 2? I actually have 3 possible ones. What's another name for angle 2? No, I don't have 3 possible ones. Sorry, I only have 2. By the way, can I call angle 3 angle Y? No, I'm sorry. Can I call angle 2 angle Y? Am I allowed to call angle 2 angle Y? Yes or no?
Yes. Because they share the same point.
They do share the same point, but I can call 4 different angles angle Y. So I'm not going to call it angle Y. I'm going to call it angle X, Y, U. That is Soldier Boy. What's the other name I can name it? Angle UYX. I have a feeling that on Monday when we have class next that we'll probably in the morning look at a few more names of these things, or at least maybe even Monday afternoon we look at some of the names of these and understand naming things better. I think that's kind of where the math part I think is going to be easy. I think naming them is going to be weird because you've never seen pictures quite like this before. Or maybe I'll just make like a video specifically about naming things. What's another name for UXY? UXW is 3. So whoever said 3, I'm sorry. What's another name for UX? 1. Angle UXY means angle UXY means I start here and I create my angle at X and I continue on to Y. So that's angle UXY, which implies 1 living in front of it. Bang. All right. So, oh, whoops. So on Monday afternoon, we'll probably review the concept of naming things a little bit more so we feel a little bit more comfortable. Don't you worry your pretty little head off. Do we understand? I think we all understand what degrees are, so I'm not going to go crazy. Angles are measured in degrees, okay? So if this is an angle right now, the angle is closed, the degree is 0. As I create more of an angle, and the angle that I create is based off of the space between the 2 endpoints. So my palms are the endpoints, okay? Or the endpoints, that common point. All right, the larger I make that space there, the larger the degree. It has nothing at all to do with where it goes. It has nothing to do with how long these hands are. I have small teacher hands, so it has nothing to do with that. It has everything to do with the space created. So right now I'm at 0, and right now I'm at like 45, and I created how many degrees here? 90. I think that's what Jill said. Okay, it's also a right angle. So the larger I make that, once I go past 90, it has a new name, and it's now like 100, 110. And once I create a straight line, which I can't do with my hands, that's 180 degrees. And a whole circle goes to 360. So if I were to put, I have a line here. Oh, I keep doing that. If I were to put like that line there and go there, we're talking a small chunk of the circle. So it would be something like 30 degrees or 25 degrees or something like that. And we use protractors to fix that. Uh-oh. Thank you. This is how we name angles. Thank you. Thank you. Everyone's blessing me. And bless you, children. Bless us all. These are the names. You should already know this. A right angle is 90 degrees. Acute angle is small and acute. That's how my fifth grade teacher wanted me to remember it, because they're small and acute. They're small and acute. Obtuse means greater than 90, but less than 180. Obtuse is in between 90 and 180. And a straight angle is 180. Okay. So we're going to name some things. I'm not going to have you copy the diagram below, but we're going to look at each angle that is written here and name them. So pay close attention to how I'm going to describe each of these angles, because this will help us with the naming part that we seem to struggle with below. Okay, this is CFD. I start at C and I go to F and I go to D, and that green picture that I'm trying to draw out is the angle that I'm concerned about. Is that acute? Is that obtuse? Is that straight? Is that right? It's acute, says Camilla. And I agree. It's small and acute. It's small and acute. What an acutie pie. Why is this having such a hard time writing? Huh. I would say that this pen is a drawlin, but it surely is not. Yes. Yes. I'm on fire today. All right, let's take a look at 6. AFD. A What acute angle? Very good. A is here. It's going to go to F, and then it's going to go to D. So I have this really wide-looking angle that's created. Okay? Acute, obtuse, right, or straight?
Obtuse.
Obtuse.
I don't know.
Obtuse says Paul. Obtuse writes Jill. And my pen's not writing really well at all. And I don't know why. Let me move that down there. All right. That's supposed to say obtuse. BFC. Oh, not KFC, right, gang? Chicken. BFC. Right is right. And AFB, I'm not going to draw it out. You guys just tell me. AFB.
Acute.
That is acute. So I think the naming things are starting to get a little clearer, and everybody's starting to say acute in the chat too. So unless we're all cheating off of each other or there's just a slight lag in the chat, that's where we are. Okay. A ray that divides an angle into two congruent angles is called an angle bisector. Bi means two. You know that because of words in the English language like bicycle. So if this guy right here, I don't know why I drew a half circle. If that guy right there, oh, can I do this? Can I do this? Can I do this? I can. If that guy right there is my angle bisector, what it does is it cuts X, Y, Z into two equal parts. Okay, so this side is 80 and that side is 80. Okay, so that's what an angle bisector is. Let's look at two videos that I created in the pen and paper series that I just started that'll help us understand the math before we actually do the math of some of these problems. Okay. Pen and paper. You're kidding me. We can watch this one first. No big deal. It is sad. Oh, angle relationships. I am supposed to find each variable. All right. Well, I have y and no information about y. I have two angles that are vertical angles, which means they equal each other. Let's not use that video yet. I don't want to use that video yet. I want to do this one first, and maybe I don't need that next video. We'll see. Let's do this one first, though. All right, this problem is a heavy-duty problem. So we are given an angle ABC. There it is. I'm supposed to find that angle measure. Have no clue what it is. I do know that ADB is 6x minus 2, and I know that BDC is 4x plus 10. What I also know is DB bisects ADC. So if this is the angle bisector, bisect literally means it cuts this guy into two equal pieces. So I can say that. I can say BX 6x minus 2 equals 4x plus 10. Since this is an angle bisector, these two angles are exactly the same, and so I'm going to set them equal to each other. Now it's just a equation with variables on both sides. I'm going to subtract 4x from both sides, minus 4x cross u out. I have 6x minus 4x, which is 2x. 2x minus 2 equals 10. I'm going to add 2 to both sides. 2x equals 12. And I'm going to divide both sides by 2. X equals 6. Now, what am I supposed to do? I'm supposed to find the measure of angle ADC, which is this whole thing. Obviously, this picture's not drawn to scale. I blame the person who drew it. I also blame his inability to spell bisects. But, you know, that's neither here nor there. He's probably a really good-looking guy, and we forgive him. So if I want to find the measure of this entire angle, the entire angle is made up from these two angles added together. So this is what I'm going to do. I'm just going to say 6x minus 2 plus 4x plus 10, and that's going to give me the whole thing here. I know that x is 6 now. So these parentheses are useless. I can do 6 times 6 minus 2 plus 4 times 6 plus 10. So this chunk becomes 36 minus 2 plus that chunk becomes 24 plus 10. And using common sense here, I get 34 plus 34. That makes sense to me because that 34 represented this angle and that 34 represented that angle. And as we know, those angles are the same. Add those up and I get 68 degrees. And that's how much the measure of angle ADC is. Such majestic music, such beautiful music. So the general idea, and let me just reverse it just a little bit. The general idea is DB, that line, literally cuts ADC in half, which means it cuts it into 2 equal parts. So we could set that angle equal to that angle, and that's how we ended up finding 6. The directions were find the measure of ADC, which means we're going to find the measure of that whole angle right there. So that whole angle is made up of that guy plus that guy, and let's plug in 6 while we're at it. And by plugging in 6, we found out that that little chunk right there was 34 degrees. And that little chunk right there was also 34 degrees because they're the same. And when you added them together, you got 68. So that takes us to these problems right here. So now you can see this problem now. You can see it now. Now you can see this now. The L's and the K's and the J's and the N's and the M's. Can you see it? Yes. So let's do 9, and if we have time, we could do 10, but I think we have time. So 9 says, well, first off, the directions say K, L, and KJ are opposite rays, which means these guys just create a straight line. That's all that part means. That just means that those guys create a straight line, which is 180 degrees. Big whoop. Big whoop. KN, so this guy, KN, bisects or cuts LKM in half. That guy cuts LKM in half. So when I want to show that two angles are equal, I put little hoops at the angles. Hoop. Hoop. Problem 9 says if the measure of LKM, so LKM is the whole thing, and NKM, wait, okay, so LKM is this whole thing. So if I were to, can I move it? Can I move it? Can I move it? Yep. So that whole thing is 7x minus 5. NKM is half of it, is 3x plus 9. I have to find LKM. All right, so this is where we are. Oh, no. It's a weird problem, but I gotcha. It's giving me the whole thing. And then, oh my goodness gracious, it's giving me the whole thing, and then it gave me half of it. So what I'm going to do is I'm going to say that the green angle 7 or 7x minus 5 is going to be 2 of these 3x plus 9s. And if you're wondering, whoa, why did he do that? Because the green part is MKL or LKM, same thing. And 2 of these red ones are going to equal that whole green one. And if one of the red ones is 3x plus 9, then the other one is going to be the same. So these guys are the same thing. So I'm setting up the fact that my green angle is going to be 2 of those red angles. So I start out the problem by doing distributive property. And so I have 7x minus 5 equals 6x plus 18. And this actually becomes quite an easy problem. Because if I just subtract 6x from both sides, that becomes x. X minus 5 equals 18. I'm not going to be able to show the steps, so I'm just going to have you guys trust me. I add 5 to both sides, add 5 to both sides, add 5 to both sides, and I get 23. Jordan, LeBron. I like LeBron. Now, x is 23, yippee-yi-yo. What was I supposed to do in that problem? I was supposed to find N or LKM. So let me erase all of this. LeBron James. Is that what Chris just did? LeBron James. LeBron James.
Did you know the Lakers won the finals?
They didn't win. They just started. They won the first game.
Oh.
Boy, is your face red. All right, so X is 23. LeBron James. I need to find out what LKM is. Oh, and it tells me what LKM is. It tells me that LKM is 7x minus 5. So if I just plug 7x minus 5, even though I know that x is now 23, I get 7 times 23 minus 5. 7 times 23, 161? What's 7 times 23? Paul says it's 161. I believe him.
7 times 20 equals 140, and then 7 times 3 equals 21. 140 plus 21 equals 161.
And Paul did the same exact thing I did in my head. Very good, Paul. What do I get for a final answer?
156.
Hey.